Well, welcome, and thanks for attending the session. About a month ago, Michelle sent me a message and said I had an opening and a presentation, would be interested in helping out fill it out. And so I went to my team and said, how about we do a presentation on some of the stuff we're doing, and enlisted one of our leaders in our construction layout team. And so he put together the abstract and got everything all submitted. And then about a couple days later, he came back to me and said, I'm not going to be able to make it. I'm actually going to be out of town. So you get me instead. So he would probably be a lot more entertaining in the presentation than I would be. But I'm going to do my best to fill in the gaps. But he is really the expert in what John Maness is his name and what he's done. So what we're going to talk about today is really this digital twin. You heard facility information models a lot, the FIM. The other buzzword in the industry right now is called digital twin, and if you think about it, it's the digital twin of the facility that's being constructed from our point, or the physical building that you will own. And so we're going to talk about some tools that we're using to capture more and more of that digital twin as it migrates over to you as the customer. So my name's Andy Berg. I, along with Brant, lead a construction technology and innovation team for Messer. There's 29 folks on the team, and we have various areas of focus. And the area of focus for Brant is our project controls group. So that's our schedule, our cost, and our quality divisions, and support of those in our group. And Brant leads our quality division, and he also runs our UAV program. And he'll talk a little bit more about that. He'll actually cover that piece of our presentation. We also cover the VDC side of the house and our work in that area, and so we've been instrumental. If you're familiar with the Xavier work, Xavier University, and the integration between Revit and FM Systems, we were a part of that. I think we presented on that back at CFTA at the IUPUI, if you were around for that event. And we also were instrumental in co-writing the Ohio State BIM standards with Brian Skurpak, who's in the back of the room. And so it's been great to see that referenced quite a bit in this session. And so it's good to see those standards are being well received. So the tools we're going to talk about today, and we'll see if I can get out of the way a little bit here. The tools we're going to talk about primarily are some of the tools that help capture imagery. And so we're talking about campus documentation. So Brant will cover our UAV program and the different drones that we use to capture from an aerial perspective. I'll talk a little bit about GPR, or ground penetrating radar, but we'll focus a little bit more on the laser scanning. And our biggest tool is John, who I referred to in the middle. As Brant says, he's usually on Heaven's Edge, documenting slab edges and edges of the building. But in conjunction with our fleet of robotic total stations that we capture data with all the time, we also have 3 laser scanners. We have, they're all Leica units. We have an MS-50, P40, and an RTC 360. The MS-50 is a robotic total station, so if you are familiar with layout equipment at all, it's the instruments that we actually will use to pull in the coordinates of a building and actually lay out a building, but it has a dual capability to actually do laser scanning. And I'll show a quick sample of what that one does. P40 is 1 million points per second, so it does pretty rapid and more high definition laser scanning. And then the RTC 360 is actually it's our newest in the fleet, and it actually is pretty easy for any of our VDC team members to take out and go start to capture imagery from that perspective. With that, I'm going to turn it over to Brant, and he'll cover our UAV.
Thanks. So our fleet of UAVs that Andy mentioned, this is one of them. We primarily run the DJI platform, which is the most common UAVs or drones in the country, really, or really in the world. So this particular model in this photo is a Matrice 210 that we use a lot. It's just one of many that we'll utilize right tool for the right usage. So we do use drones and for a couple different purposes. One of those being kind of the pretty pictures, the marketing photos, your progress updates, which all look cool. They do provide provide some value, but we've really dug deep in, what are the other things we can do with these drones other than just take nice pictures and progress updates. So those would be inspections and mapping, as well as and thermal imagery. So this is an example of an inspection. It's actually one that I did on a large campus customer of ours, a university, actually University of Cincinnati. This was a building we recently turned over, but we did a full flight of the building, and I looked at every single caulk joint on that project. So I utilized actually a 30 times zoom camera lens that we have for the Matrice 210 to capture this head of this window detail here. And we found a couple different spots that, it could have led to some problems. After the exterior contractor finished their work, we did an inspection, found a couple issues. If they weren't caught, could lead to some leaks in the future. So super valuable tool from a QA aspect, which is where I focus, to really make sure that our product is a good one for our clients. So using that zoom lens, provided that level of detail from, I was 30 feet away from the building. So that previous photo that you saw, that was actually where I took that photo.
I'm sorry, did you say this was a newly completed building?
It's newly now completed. Yeah, this was during construction. So the next use cases that I mentioned was thermal imagery. So these two images on the top and bottom left are actually from a dual lens setup that took RGB imagery as well as the thermal signature from that same. This was 20 stories in the air, and see the heat signature off of that window system. On the right side is an office building where we flew the roof system on the top right, and then on the bottom right we flew the exterior envelope and looked at the thermal capabilities of the insulated metal panel system. So you can see the different heat signatures that can come off, and the thermal imagery can lead to quality control, such as roof leaks. You can detect roof leaks looking at thermal signatures as well as insulation issues. So this next slide is getting into the mapping, or really photogrammetry technology. So it's where we fly a construction site, fly a campus, fly whatever property that you want in an organized manner. The software which we use is Pix4D. We'll take those images and build a 3D point cloud from that, as well as an orthomosaic image. And what we do to provide even more level of accuracy and tied into campus coordinates is utilize ground control. So this is just an example of an arbitrary point I clicked on a target that shows you the rays to the various images that were captured in that. But the ground control gives us about 2 to 4 centimeter accuracy with the drone imagery, and we'll get into that's kind of a high level accuracy, and then when we get down to more finite accuracy with the laser scanner, but this does give us great site information so that we can start capturing further data. This next video is from a zoo campus where we did some pre-construction work on. So we flew the campus after hours, captured the whole about 60 acres in a matter of a couple hours. Ran it through the photogrammetry software to put together this point cloud. It's all colored and nice looking. So this is just flying through that point cloud. From there, we took the data from the point cloud and brought it into Civil 3D, which is what you see here. So we can start to refine that information and start to really put some meaning to the points. So this is going to show putting some line work to those, and then we'll get into some further examples of that. But we can take the line work and add things like topography that we can extract from it, building outlines. So this next, where it turns on you can kind of see it, probably hard to see from the back, but there's some light green lines and some white lines where we can start to extract line work out of the point clouds. And then ultimately we turned it into a kind of a pretty picture model in InfraWorks to help show the client the campus a little bit better. So this is an example of a smaller campus, but we again flew the drone on this campus after we had a base civil site plan already completed from our surveyor, and then we demoed some buildings out, and then really filled in this area on the map after we demoed buildings and a bunch of trees and leveled out some areas. This is from a healthcare campus of ours where we really used the drone for a tool to evaluate some temporary parking locations. So we were evaluating this space here that was adjacent to a creek to see if it would provide enough parking while we build a new bed tower for this campus, and it gave us good information. And it was the easier site other than this grassy area, and help the client, or help convince the client that we should put that temporary parking there.
And that helped with the creek runoff too, right?
Yeah, it did. We were able to identify the proper drainage put in place to keep that creek flowing and the watershed right. So this is a smaller building project where we had a small septic system going in, as well as some underground electrical conduit, and just from the UAV, we're able to, in the point cloud, we're able to extract some CAD work to document those locations from those point clouds. So for UAVs, we start to lose that accuracy that we need for buildings. It works great for the site, but in the building world, we work in an eighth of an inch accuracy. So that's really where the laser scanner comes into play and helps us capture information. So we're able to blend the two together by geolocating the point cloud from the drone. We're able to then blend it in with the laser scanner information, so you can see it's really seamless that we can go into this point cloud, start from that drone level accuracy, and then zoom in to where we have the laser scanner data embedded, and so we can get accurate measurements like this window, for instance. So we can get that 32nd of an inch accuracy level versus that 2 to 4 centimeter accuracy level. So with that, I'll hand it over to Andy to talk about laser scanning.
Yeah, so a couple other examples, as I mentioned, around the laser scanning piece of it. This was an example where the owner had an issue with the drive, and this manhole over here electrical manhole was actually filling up with water, and the owner was concerned that the pavement was the problem and that it wasn't put in the right location. So our MS-50, which is a robotic total station with the laser scanner, was able to go in, quickly did a point cloud of the intersection and that manhole, and then we were able to get the elevation on that manhole. And what we're able to do is cross-reference this back to their drawings and found that the pavement was actually exactly where it was supposed to be, and it was the manhole that was actually set 2 inches too low. So their solve was actually pretty simple. It was to raise the manhole 2 inches and resurface right around it. So, but that was done rather quickly to get that data out. This is more to laser scanning the campus, as Brant was saying, is that the UAV is great for the site, the upper level, but when you want to get granular and down to the ground, you move to laser scanning. This is Vanderbilt University in Tennessee, and one of the things that UAVs struggles with certainly is tree cover. But this is an area that we had to get really accurate with, because this is the building footprint right here, and we have these utilities that are going in, and then we have crossing utilities that are existing. So the university asked us to not only document our new utilities, but document any crossing utility that we find. So this is a little bit more of a blow up, and probably hard to see, but you'll see crossing utilities, crossing conduit, crossing utility piping from their central utility plant. And then this would be a bigger blow up. This would be the crossing utility, and then the new utilities underneath. So we're actually able to document all that and give that data back to them, so that as we go, we're actually documenting with more accuracy some of the systems that they may not have had.
So can you tell what the utility is?
We can cross-reference back to their whatever files they have and try and pick it up. Other than that, maybe by the size or material, then it would be able to pick it up, but there wouldn't be any.
And if it was a full colored scan, these weren't the full color scans. These were just elevation view, but if it's labeled right, you can tell.
These are open trenches where you scan
Yes.
the pipes.
Yes, absolutely, open. So we would shoot this, obviously, and we try and document. Before we cover up any pipe, we want to go in and shoot it to make sure we've got the correct coordinates on all the piping. So I want to talk a little bit about ground penetrating radar. This is not accurate, but this helps us really identify where things are thought to be, or we want to kind of ensure that we're not going to hit a utility. So ground penetrating radar actually will shoot radar down through the ground and try and pick up information to detect metal in this case. So this is Xavier University. There was thought to be something in this area. This is an old industrial site, so there's a lot of buried things. On our hub project we just completed, we found a lot of old foundations and a lot of toxic or hazardous materials from some of the former manufacturing plants that were there. So this is the same condition, not too far from that same location. So we kind of knew there was some site utility conduit in this area, and we were trying to confirm the tanks that could be in that area. And so as you can see by this image, the ground penetrating radar did confirm an underground storage tank in this area. It did find more here, but not as much as was thought. And then this image actually shows you the data that comes out of the GPR. And this indicates where that underground storage tank, so it's picking up the metal of that tank, and kind of it does give them a pretty good feel for where that tank is located. But it's not something we want to, so after this point, then we would go in and definitely find it and either document it or remove it. But it's not something that we would give to you as a customer as, hey, take this to the bank, this is accurate and where it's going to be. So in this one is the example of where that site conduit is, closer to the surface to the top, or closer to the surface. So great tool to be able to see in the blind underneath the earth to a certain degree. So where all that comes to is taking all these different tools and honing in on the data that's important for you, primarily from a site or a building exterior, and getting it to GIS. So, and this is where John could get in a lot more detail as the expert. So we had our first GIS deliverable from requirement from Eastern Kentucky University, who has a strong spec and a front-end requirement for delivering an Esri-based GIS file. So John actually took all of our data and actually added the content and converted it to become the GIS file for Eastern Kentucky. So this is the big file. This probably doesn't do justice, but then this is the file that was submitted to them that contains all the GIS information that they were requesting. So we believe this is going to be more and more the future deliverable from you all as we document and can confirm all the information that is part of the project, and not only turning over the model for the information within the model, but also turning over the exterior information and the GIS information. So with that, knew we only had 30 minutes, so we'll go ahead and open it up for some questions. Yes?
Can you talk a little bit about what your approach is to areas that have a lot of tree cover? You mentioned it, and
Mm-hmm.
what is the solution? Our campus has a lot of tree cover.
Yeah, so it would depend on exactly what you're trying to go for. So if you want just kind of an overall campus map, start with the drone information. So that would actually be closer to this. This was Norton Hospital in Louisville. See if I can get back there. So this was the starting point from the drone. So it documented everything it could. And then where you have high tree cover, then you go in with the ground, with the laser scan. We also did it on the zoo. We actually brought the laser scan in specific areas because zoo had a lot of tree cover too. So wherever you can't see based on the tree cover, you go in and do laser scan. And then so this is a blend of a laser scan and the UAV data. So it's one point cloud. But in the end, it doesn't matter, right? So use both tools to get the data you're looking for. Yes?
You mentioned your deliverable at the end. How are you, what attributes are you coding for the level of confidence of the utilities that you've documented? Is everything to that, level of the laser scan, or is it, well, we found it here and we couldn't see the rest of it, we don't know where the rest of it goes. So that section that you uncovered is great,
Yes.
really well documented, but we don't know where the rest of it goes.
Yeah, so we only document what we can see and what's exposed. So unless the university has more information and they want to make the tie, so maybe they had information on an existing utility, and that's maybe just a confirmation that it is what it is, because they may not have, when it was put in, they may be working off drawings, and that may be what they've been basing their whole site map on. This would be just more of a confirmation of, okay, we did locate that utility and it's in the location that
And
it
when
seems.
you do that deliverable, are you keeping a Z value, or is it just flattened to 2D and you're just?
I believe we were capturing the X, Y, and Z of everything because it's easy enough to get with all the tools. So
Yeah, like I said, we try and get as much information before it's all covered up through the instruments, and then we have it, so how we deliver it is based on what you all ask for. Yes.
Questions. Do you own the GPR or do you have a subcontractor?
We have a subcontract. We actually have ownership in another company that actually locates utilities, underground utilities, so we leverage them.
Okay, and then back to the UAV. I haven't done much of this myself, but your example had ground control you shot. If you don't use ground control for a less accurate need, the drone has GPS in it, right?
Yeah.
So that you have a lower accuracy for that, depending.
yeah, it's a little bit like we've done a lot of sites for like stockpile analysis, to verify like hauling of excess spoils. We've gone ahead and just flown some of these piles without ground control, and it does degrade the accuracy, but what we found is it's pretty negligible in that regard. I mean, it might have been plus or minus half a truck or one truck worth of difference in material, but
Georeference.
it does georeference to a state plane by default. So
What's built into the UAV. Okay.
yeah, yep.
It's hit or miss on, the accuracy of
It-
how good it is.
yeah, it can-
Maybe if you have control, but.
It can really fluctuate, to even 6 inches. If you don't, the more. And then there's a lot of, depending on the level of satellite coverage you have and how many satellites are connected to it, definitely play into that. But
Yeah.
for a lot of things, you can get pretty close depending on the workflow. So we'll try to do, again, our teams and we're equipped with the tools to lay ground control pretty easily. So we'll go ahead and do it.
Yeah, since they're part of our team, it makes it a lot easier.
Your guy on the roof, I did that for like 15 years. And I was never a 32nd of an inch good. But
Yeah, that one's still, even when he
Yeah,
sees that
goals,
picture,
right.
it scares him today. so.
Try to get there.
Yes?
With kind of the emerging new technologies like drones several years ago, is there anything that geospatial has been able to do or can now do that you guys see as necessary for engineering techs, for field engineering techs to have? that hasn't been a norm because it wasn't capable? So is there anything that you see that's innovative that you wish engineering techs could have their hands on as far as a process data set or working together in the field?
Well, I think when you mean field engineering, you're talking about the layout
Well,
folks or
historically, we had geospatial techs and engineering techs, and the
Okay.
two didn't really play together because the data wasn't cost-effective, time-effective, et cetera. Well, things have changed. So now we have a question of what do construction companies see as, man, I wish my engineering techs had that, whether it's a skill set or deliverable from a geospatial tech.
I think he's talking about from an education standpoint. You know,
Yeah,
what would
retraining.
those engineers need? Probably more the Revit, the Civil 3D skill set, for sure. But there's a lot of still back to the basics. Understanding coordinate systems and base level surveying. Knowledge is still going to be.
yeah, with these instruments, I mean, our robotic total stations are the rod is the smart end now, right? So it's one man total station. We used to take two, and I mean there was a lot of math involved. Of course, there's a lot of human error, but if we're just simply taking all the coordinates out of the model and taking them into the instrument and going out, we still have to have the smarts of making sure that that information is correct. So that's the thing that we have to be careful of, is we can't just rely on the machine and the information that we're getting. We do still have to know the surveying basics, and we do still have to know how to validate that and make sure it's accurate.
And even the carpentry, the basic carpentry basics of, knowing offsets. Why do you need an offset to, set a column or a wall, and knowing how to set lath and batter boards and all that kind of good stuff.
But from our perspective, again, something we've been evolving over the last several years, which is better documentation of the things as they go in. And I think that's where we're seeing construction surveying change. It used to be a lot of work to go out and lay out a building and make sure it was going up as planned, and making sure your control points weren't getting covered up. That was my first co-op job on a 32-story office tower, so I learned pretty quickly how fast you needed to be paying, how you had to be paying attention to the work that was going on, and when you lost your point and how hard it was to get it back was always a challenge. But now we're really starting to see their time freeing up to where they're actually doing more record documentation. They're actually, if I had more time, I'd probably show you more of the heat maps that we'll do for floor flatness. We'll do a laser scan of a concrete floor, and we'll know instantaneously where we got deflections in it or humps, or where we would have to. If we've got an FF or FL rating on the floor that we're going to have to address. Documenting slab edges and knowing the frame of a building is so much faster and easier for us to document these days than it would have been. In the past, we'd have to string piano wire down on the side of a building and then measure the in and out, make sure that wire got pretty tight to go document a 12-story building. So I think that's an interesting piece that we're seeing the move toward, is more helping the initial information and then documenting the as-built or record document. Don't know if we answered your question, but.
Yeah, doesn't matter what you say, it's the fact that you are who you are and you say something. That's the right answer.
Yes.
Yes, so as you have a building in construction going up, you've documented it, and now you turn it over, documentation to the owner, and such as the old days of now, you do photographs, you put those once a week, you binder photographs, you turn it in laser scans and drone imagery, little photos.
Yeah, we can, but everybody has to be able to receive it and understand the data that they're getting. We give you a laser scan, you're probably not going to know exactly what to do with it. So, and you're not going to open a raw laser or point cloud, so we have to prepare it so it's usable for you. So if we've got the scan data, we have no problem delivering it. I think the difference in where we're seeing it is that scan data is great, but then converting that information into GIS so that it's ready to go right into an owner's system day one, so that they've got the data. But the laser scan, the photogrammetry, we're using tools like these 360 cameras, which are doing we'll walk a job site with a 360 camera once a week. It's documenting progress. That all that imagery, it's photogrammetry, and that's more documentation of that digital twin. And that's all information that can be turned over to the customer at the end of the day too. I know like Ohio State actually uses 360 cameras in every room, and they document their facilities that way. So when you go into their work order maintenance system or space management system, you'll actually see a 360 picture. There's no reason we can't deliver that same information to feed those type of systems as well.
It can be kind of information overload if we just spit it all out. So we really try to tailor that to.
Or we can at least a 360 picture of the rooms before the sheetrock goes on.
Yeah, and that's what's pretty interesting. You can actually do what they call X-ray, where if you document it before the sheetrock goes on, then later down the road, you can actually open up the app and turn on the X-ray mode and then peel away. On the iPad, you would actually see the wall, and then you can peel away the drywall and see the utilities behind it. And it's all it's doing is exposing that in real time, geo-reference that wall and pulling that picture in time.
I think that so people will go up at 10 years later.
Yeah. Challenge is what's changed in those 10 years, because that picture was from 10 years ago. So that's you as owners have to kind of keep that up somehow. But these 360 cameras and that technology is rapidly improving. So in 2 to 5 years, we'll be talking a whole different story, I believe.
And they're so cheap too.
They are.
You can get a Ricoh 360 for $200 on Amazon, and if you know someone tore open a wall in a bathroom,
Yep,
you go and take
just
a
go do it.
picture.
Well, I firmly believe, I mentioned the 3 laser scanners. I probably got $300,000 worth of laser scanning equipment. We got more than that. And I believe these things are starting to get, these will get to the point to where the photogrammetry and the imagery they can pull off, we probably won't be using those. Hopefully we'll be using them in 5 years, because it's my payoff on them, but hopefully it's sooner than that. But I believe the technology is going to improve, and we're going to be documenting much faster all the time. So I think we're out of time. So appreciate your time. Thank you.